Good morning, everyone. I'm Brad Green. I'm the manager of the Angular project here at Google, and I'm joined by John and Darrel from Tickle, and they're going to talk to us about building Chrome apps with AngularJS. And I'm sorry, you guys, for this holiday edition, John's actually wearing some spectacular Christmas pants, but you can't see it on camera. We'll maybe at the end we can get a shot of that. So, hey guys, tell us a little bit about what Tickle does before we get into the presentation about building apps.
Sure. Yeah, we're mainly a mobile app company. We have several communications apps. We have 3 on Android and we have 4 on Android.
Yeah, 4 on Android, 2 on iOS.
2 on iOS.
Right.
So we've got Tickle, which is like a walkie-talkie. It works just like a walkie-talkie. It's pretty fun. We have Talkray, which is our kind of main focus these days, which is a unified communications app. You do texting, calling, does groups up to 25 people. KeyChat, which is what we're going to be talking about today, which is group texting with usernames. And then we have a new app out that we launched a couple weeks ago, which is a PTT recorded app, so you can send voicemails back and forth. It's called the Messenger.
So you guys have been primarily doing Java and
Yes.
Maybe Objective-C development, and you've just recently come into sort of the web way of developing things.
Right.
And so how long have you been doing this?
We've been, since we started as a company, it's probably like 5 months or so. We've been kind of jumped into this, right?
Yeah, we started over the summer doing the web stuff.
Yeah. I mean, both of us have obviously dabbled, in a lot of web stuff before, but this is like our first kind of real larger project.
Yeah, right. Definitely the first big project, and the company, as a company, doesn't really have much experience with web things. Tickle was started in 2010. They had the Tickle app for a while, and then we jumped into Talkray, and that was iOS and Android. And we've basically been focused on mobile exclusively until this project.
Okay, very cool. All right, well then let's jump into the presentation and tell us about what you guys have learned about the environment.
Great. So we can start with the slides. So this is KeyChat.
Yeah, so these are just a couple of screenshots of what the mobile app looks like. So basically, like what we said, it's a unified kind of messaging app, so you can send regular texting, images to anyone within our system.
And we recently built a Chrome app out of it. We started with a web version of this, and then we sort of transitioned to a Chrome app. And we talk a little bit about why we picked Angular and Chrome.
Yeah, Angular really kind of fit with, like we said, our background in Java. We wanted the kind of look and feel of the entire thing to be very much like an app, less kind of a traditional web style of doing things. And everything like the MVC architecture of Angular kind of really fit into the pre-existing model that we had kind of built everything around on the mobile side. Right.
Yeah. It was very comfortable for us to look at, because it felt a lot like being able to build an app. And you can see here kind of the structure that we chose for KeyChat, which is basically Angular's suggested structure for especially large projects. So we broke it out into controllers and services and models are the kind of the main components here. Trying to pick apart with the MVC architecture. Do this properly, and it was really nice to have services for us coming from Java, where they're sort of like singletons. They work in a similar way. So there's a lot of nice stuff, and kind of organizing your code like this really helps in larger projects.
Yeah. So I guess one of the things is like, why do we chose to do a Chrome app kind of off of the Angular app? Why not just keep it a website kind of thing? So obviously the biggest one is the Chrome Web Store, right? It's a great way to get distribution for our app. The other one is that like I said, we really wanted to make it feel like an app. We wanted users who came from our mobile to be able to experience the same kind of experience that we provided on their computers. So one of the big things is notifications. That makes it kind of feel like a much more rich experience. And obviously, raw sockets were pretty important for us because we're a communication app.
Yeah.
So, you know.
Yeah, right. We'd sort of played around with a couple of different socket clients and decided that for us to get out the door, raw sockets was going to be the easiest way for us to do it. So that was something that was available in Chrome apps that really you can't do in HTML5. There's WebSockets, but it's not the same thing. Like Java can use WebSockets in Java 7, but we're not running Java 7 on server, so.
Yeah, so some of the tools we use are, we just briefly go over this: Yeoman, Grunt, Bower, and Karma. Karma is our testing suite. The other three kind of just really help us, organize our code a lot, bring in all the dependencies, kind of keep everything clean.
Yeah, it's pretty standard stuff, and it was really nice with Grunt actually. You can run Grunt server, and it has like listeners for things, and so it was really funny because when we were really kind of running through this stuff, it was faster developing on the web than it was in for Android, because you'd change something and then your browser would get updated right away. It was kind of funny from
Yeah, we were just used to kind of waiting, compiling, and doing all this kind of stuff for Android development.
Yeah, and we didn't even have to hit refresh on the browser window here, so it's kind of nice.
Yeah. So one of the main concerns when you're thinking about building a Chrome app is what are all the dependencies in your project that you're going to need to kind of rework around the web app or Chrome apps. Sorry. And one of them, kind of the big one, was require.js. So we used require a lot. It's a great kind of modularization tool that you can use, library. A lot of people use it, right? It's a very common thing. But they kind of conflict a little bit with the module system in Angular. They don't necessarily directly they're not against each other. In fact, that they're kind of orthogonal ideas, the way they treat modularization. But they are going to step over each other a little bit. So you got to understand if you really need it and how to kind of deal with it.
For us, we had all these third-party libraries that we just kind of had to use, and some of those required require. So it's okay, we're stuck using require. It's kind of painful to get implemented properly with Angular. If you can avoid it, it's probably better to avoid it.
But it's still a great tool, and if you need it, there are several resources online that kind of show examples of how exactly to do it. So it's not.
There's
ways around it.
And I have read that Angular is supposed to be getting better about trying to integrate with require.
We do want to work on that more. Yeah. So like you say, these are two orthogonal things. One is about what does my JavaScript class need in order to run. The other is what order should I load files in.
Dependency order and then lazy loading and things like that.
It would be nice if these worked well together. This is some future thing we'd like to get right.
Yeah.
Right. So I guess now we're just going to dive into what the process of converting a web Angular app to a Chrome app was.
So just kind of the quick few basics that every kind of Chrome app needs is that it's going to need a manifest JSON file that pretty much describes all the permissions and the app name and things that go into the store. There's going to be a background JS file that is kind of describes several entry points into the app, like what happens when you install the app, what happens on launch. And you're going to need obviously your index file is your main index file. But there's a trick to this one is that it sometimes differs from what you normally would have in your Angular project.
Okay, so we can look at the manifest here for a little demo app that I did, and it's really pretty basic. You've got your name, description. You have the entry point of the JavaScript for your app defined, which is background.js. It's a pretty standard thing within Chrome apps. And then permissions. So, for example, I need to be able to talk to the ajax.googleapis.com site, and I also need to have storage permissions. And then you also specify your icons.
Yeah, pretty straightforward. And like I said, for the background, you can pretty much describe kind of generic things about your Chrome app. So in this case, all we said is the width is going to be 1200, the height is going to be 700.
Yeah, and then your index is chromeindex.html.
Right.
And you can name it whatever you want, but I don't know. I think it's easy just to call it Chrome index, and your regular one's index. So.
Right.
Okay.
So once you kind of add all these things in, you think, okay, this is gonna, things are gonna look good, and you try running it. Of course, nothing nothing works, right?
Yeah, you get a lot of red.
Right. And so one of the main kind of first ways to kind of approach this is there's a thing called a content security policy that web browsers implement. It basically kind of restricts what you can do so that third-party kind of external code kind of doesn't maliciously run some hacks on your website and cause all kinds of problems, right? So this is something that's already out in most web browsers. But then Chrome apps have a kind of a tighter restriction on this content security policy. So the three main things that kind of differ from traditional web is that it's going to restrict any inline scripting. It's going to restrict any external resources. So if you link to some extra library somewhere else, you can't necessarily just link to that to bring that script in. And it's going to restrict anything that pretty much converts strings into JavaScript. So things that use the eval or new function methods are not going to work in Chrome apps. So the second thing that I talked about, the external resources. So the first thing you're going to look at is what third-party libraries you bring in that you might actually reference from a CDN or something. These you can't bring into your app directly, so you're going to have to download these libraries or any kind of styles or fonts, images, any other kind of static content that you might be able to just bring into your app and have it hosted straight from there. And so you're going to have to modify your index file, obviously, because that's where all these things get referenced. So here's a quick example of how the index that you might have for your regular Angular project will differ from the Chrome one. So at first one, when we reference the app, there's going to be an ngcsp.
Don't think it highlights.
Yeah, it doesn't highlight. There's going to be an ngcsp Angular tag that you're going to put there. What this describes is that it tells Angular to be in CSP mode, essentially. Angular has a lot of optimizations that kind of use things like the eval and new function, I believe, and basically it's just to optimize Angular. But for it to run in the Chrome app, you have to restrict those kinds of things. So it has a CSP mode that'll get around.
It's
that.
Actually only a few little things. You don't lose very much at all.
Okay. Well, yeah, great. Yeah.
But it's one small optimization. But yes, you do lose it.
Right. And so you do need to specify that. Mm-hmm. And obviously, now that you downloaded, say, in this example, it's a socket.io, we were referencing it from a CDN, so now we just have to bring it into your own project and reference it that way. Pretty straightforward.
Yep, and then you try running again, and it's still broken. Right. So.
Okay, so here's a little demo. Let me switch. Here's a little demo of a socket app that I made. So basically, all this is it's just a small little test demo that connects to a Node.js server. The Node.js server starts counting every 1, 2, 3 every second, and it will reply back on socket.io to the client and display what the current count is, essentially. Really simple. That's kind of all that's happening. And so here you'll see that the counter is incrementing, but at this point the Angular project doesn't know anything about what the count was previously. It doesn't know anything about like who his friends are. These are all kind of initialized and given to us by the Node server. How do we get back?
Yeah, just you don't want to dive into. Okay.
Well. Oops. There we go. Okay. So one of the key components to Angular as well as Chrome apps is that the way you think about web servers traditionally is kind of switched to be using an API server. So the web server you need to treat as an API server. And what that means is the web server is not going to hand down like HTML or things like that, where it's traditionally like they might have injected information. Say you grab information from your database, you put your friends list or something, for example, and it's not going to inject it straight into the HTML and then hand you back the HTML. Rather, all that's going to exist in your Angular app already. And really, what your server should be doing is sending back just the data, none of the UI components. Mm-hmm. So in this example, this is how the HTML looks like for the example I just showed you. Pretty much all we know on the Angular side is that there's going to be a count. There's going to be a count listed here. Oops, that doesn't do that. Okay, there's going to be a count this reference there. And we're going to be repeating over a list of friends, but we don't know who the friends are at this point. There might be one friend, there might be hundreds, we don't know. But really, you need to treat your web server to give you those things as an API server.
And this is the great thing about Angular is you're going to build your app this way anyway.
Right.
So there's not much in the transition.
Right.
Exactly.
So we're going to look at socket.io.
Okay.
Here. Whoops. Uh-oh. That's not good.
Okay. So here is some of the code for this example. And this is all, by the way, on the public GitHub repo so that you can look at it later on your time.
Yeah, we have links at the end. So.
Right. So this is the main controller for the example I was just saying. So basically, there is going to be a count that's initialized to 0 and an empty friends list. Like I said, you don't really know anything about what's happening. And the way we have it structured is that initially you just connect to the server. The server is, like I said, a Node.js server that's running locally. And here is the service that controls the communication to that Node server. So in server connect, where you start off, essentially we just connect to, I have a hard-coded thing to localhost right here. And at this point, we don't know any kind of data that's been passed through, right? We just know that we've started with nothing. So what we do is we tell it to connect, and when we connect, we event and emit back to our controller saying, hey, we've connected. And at this point,
actually, Darrell, maybe bump the font up a point or two here.
Sure. What was it? Command plus?
Yeah.
There we go.
That'll be good.
Sorry about that.
So in the controller, when you do connect, we're going to tell it to initialize. Initialize our state, right? So at this point, your API server doesn't really know anything about where you've left off or what it is. It's just going to start counting from from 0 if the server doesn't know anything. Mm-hmm. So it helps if you pass in some kind of initialization data to tell it, hey, this is where we left off. And this kind of leads into a key point of how you want to treat offline and online mode, but we'll get to that in a second. And so we initialize it with our current count, which at this point is 0. And when we get a response back from the server here on init response here, we'll get back some data. And in the data, like I just know, it's going to contain the current count and just a list of friends, which doesn't really change. And then from that point onward, the socket's going to connect. It's going to listen for a counter update event that's going to get pushed down once every second from the Node server, and it's just going to emit the count right here. So the count is actually incremented on the server side. So all that kind of logic, obviously this is a kind of contrived example of what you might want to pass down, what information you want to pass down from the server, but essentially the server is going to be handling all that kind of data management, a lot of that stuff that goes on. But you'll notice here that this is all kind of just standard socket.io stuff if you have worked with it before. How do we get back? This way. Right. There we go. Okay, right. And so one of the things that you have to consider when you build your Chrome app, and for Angular as well, is how this is going to get treated in an offline mode or in a state where you're not sure about the connectivity of things. So you do need to handle things like disconnections or crappy connections, and a lot of that needs to go into any kind of socket code that you write. So luckily, socket.io handles a lot of the disconnect and auto reconnect logic. But if you're working with raw sockets, you're going to need to handle these kinds of things as well. But more than just the actual connectivity, you need to think about how your app is going to kind of work from the user standpoint when you don't have connectivity, right? If you start off the app, will you be showing like a blank page, right? If you lose connection in the middle, what's going to happen to, let's say, in our example, the counter that you have going on, right?
Right. You don't want to just like throw up a refresh button and make the user think about that stuff. You want to kind of handle it in a smart way, so that it's kind of as automatic as it can be.
Right. So in our example, can you, what's it called? Terminate the server.
Oh, this okay. Yeah. There we go. there. Okay.
Okay, so we
Server's
just
dead.
killed our server essentially. When you go back to this, you notice the counter is stopped, right? You'll probably want to do something to signify that you're in offline mode, maybe. That might help so the user doesn't get confused, like why isn't anything working? But you notice that the count is just stopped at here, right? But if you were to redo the server or reconnect it, after some retry logic, it's going to essentially start back from where we previously were counting. So you don't want to necessarily start from scratch every time you reconnect, right? You want to leave the user off where they were before and kind of smoothen the transition between these things.
Right, you can see it worked. Where we were stuck at 419 and now we're counting again.
Right. So you don't necessarily want to start at 0.
Yeah.
Every time. Yeah.
Okay. So let's see, we'll go here.
So this whole example was obviously just a regular Angular app, and the same thing works for. Same thing works. The transition from bringing Socket.io into Chrome apps is really, really simple. Pretty much like what we showed earlier, where you reference the Socket.io not from a CDN, but from your own project. After you do that, that's pretty much it. There isn't a whole lot of things that you need to do to get Socket.io working. It actually just works kind of out of the box.
Yeah, which was really surprising to me because I thought that this might be restricted or it might be really difficult, but Socket.io is just just works. Where do you want to go?
Yeah, there we go. And so, on top of Socket.io, Chrome Apps provides a really great sockets API. It gives you access to raw TCP and UDP sockets. It's through the chrome.socket API. I have an example on the GitHub that is the same exact demo that we just showed, but just rewritten for sockets, for TCP. So if you want to look at that, here's a link for that. But we don't necessarily won't go into that code. Right
yeah, it's a little bit more verbose, but it's also a lot more powerful. Like I mentioned at the top, like you get access to real raw sockets with this, which, like I said, we just needed for our app.
And just so folks can think about which one would I need. What did you guys need the raw sockets for?
So we're sending binary data back and forth to the server. Socket.io sends back and forth strings. So if you want to send that sort of data over Socket.io, you have to encode it as a string first, and then you have to decode it on the server side. You also have to have server-side components that can handle Socket.io. Depending on the server that you're running, the sockets you might have a good Socket.io library available to you. Like if you're running Node, it's really easy to just pull in Socket.io. But if you're running Java, there's not really a great solution for Socket.io. So it's a lot easier to use raw sockets there.
It just depends on what your current architecture is and structure is. For us, since we came from a mobile app with a pre-existing system, it was easier to plug into that rather than recreate everything, in a different system.
Right, and there's also web sockets too, like we mentioned, and those are maybe a little bit more available on servers. So.
Cool.
So it just depends on what your needs are, but it's really nice to have Chrome sockets available.
Yeah.
So the next thing that you want to think about in terms of how your app behaves when it's offline is your local storage stuff. And this is actually something that I started with in my demo, which is a little podcast app. Before I even thought about converting this into a Chrome app. The main reason is because I wanted it to behave like an app. I wanted people to be able to subscribe to podcasts, and then kind of listen to episodes. I wanted it to keep track of how much they had listened to so far, so that one thing that really drives me kind of nuts is I have a couple tools that I use, aside from my app, and for listening to podcasts, and they always forget where I left off. And some of the podcasts I listen to are multiple hours long,
Right.
And if the thing goes down or you accidentally click refresh and you start back at 0 when you're an hour and a half in, that's not too fun. So so this stuff is is really important. It's really useful, and storing stuff on the client side in certain cases, like for KeyChat, for example, all of your chats are stored locally. Your contacts list, you want all that stuff local, especially if it's just going to be for you. There's no reason to have it on the server. So there are some slight differences between how Chrome handles local storage versus how HTML5 handles local storage. And I will show you right here. So the big difference is that HTML5 is synchronous. It has a synchronous API for local storage, which means that you can just say, my val equals local storage key, right? So that's just getting the thing right off a disk. It blocks inline. So you're going to be blocking on whatever thread you're calling that on. And Chrome is asynchronous. So it's going to go out to disk and then return in a callback the thing. So you can just follow along here. I highlighted in blue the value that I'm trying to set. And in like orange here is the value that's coming back from disk. So in the HTML5 example at the top, it's just one line that we have to call. But again, it blocks there. And then the example below is a little bit more verbose. But you can see, we start out with null set to that, and then we define a callback function that's going to take a single parameter and assign it to the value that we want to set. Oh boy. There we go. And then we do this chrome.storage.local.get, and then the first parameter is the key, which is the same key that we have up above. And then that's going to, whatever gets returned is going to get passed to a function. And it's going to be callback and then data key. So you get an object back and you have to pull the value out of the object. It's really not too tough. It's just slightly different because it's asynchronous. And the big deal here is that there may be some third-party libraries, especially if you're in a larger project, that make assumptions about having this synchronous API for local storage. So there was one library that we ran into that was a pretty integral part of KeyChat that just made assumptions all over the place about local storage being synchronous. And we made assumptions, we kind of used their API in a synchronous way because those were synchronous calls. So it made sense to use it in a synchronous way. So what happened was when we did this change to Chrome, we had to kind of go through and rewrite quite a bit of that third-party library to make it function asynchronously. That was kind of one of the more painful things. It wasn't a huge deal, and it wasn't technically difficult. It was just kind of annoying because you have this dependency and it's kind of not working for you. So. That's stuff you might run into, but
right. So pretty much you always kind of want to check and see what kind of assumptions any third party makes on the access to the APIs, as well as the thing like we talked about earlier, the content security policy. A lot of these libraries are going to make assumptions. A lot of them kind of more towards the way web has been done up to now, right? Mm-hmm. And not kind of the way the Angular way or the Chrome app way. Mm-hmm.
And another great way to persist data locally is with IndexedDB, which is an HTML5 API. And it can actually be a much better fit for certain types of data. So if you have larger data sets, anything that's not a string really, you probably want to use IndexedDB. It's a NoSQL database on the client. The API is a little, it takes a little getting used to. It's a little verbose. I actually wrote a wrapper to kind of help with doing things with Angular. So it's an AngularJS IndexedDB wrapper, and so that you can just kind of inject it, and then you just do much simpler calls. But here's an example of IndexedDB put. So you have a data store, you have a database. The store name is kind of like a table. It's it's a data store for NoSQL. And we're just going to put some data, which is an object, so it's going to be key value pairs in that object. And so you need to get, so you have a reference to the database already. You have to have opened the database, and there's kind of a whole process for that. And then you get a transaction with the store name. It has to be in read-write mode if you're going to be persisting things. They say, object store.put, and then your object. And then hopefully you'll go through this on success callback that has your event. And then what I'm doing here is I'm emitting an event through Angular, through the Angular scope, that this data was put, and then on what database and what store name. And then I have a similar event in the error case.
And this whole wrapper is put as a Angular service, right?
Yep. So it's a singleton. You can call it when you set up your app. I tried to make it as simple as possible, and we actually used the same library in KeyChat. It cut way down on the amount of code that I had to write over trying to do things with local storage.
And you'll be able to share that link with folks.
Yes.
At the end.
Yep. It's at the end.
Great.
So I actually also have a wrapper for the local storage to kind of choose between Chrome versus the HTML5 thing. It tests to see if Chrome.storage exists, and if it does, it uses that. And you can also set it up to use the sync Chrome.storage.sync versus local, which will sync any of those strings across multiple instances of Chrome. So if you're logged into Chrome on your laptop at home and your laptop at work, you can actually have that stuff synced up, which is nice. So back to the slide. Angular has, it's just an aside, but Angular has these really nice event emitters. In KeyChat, we used a third-party event emitter library because we had, like I mentioned at the top, there's some third-party libraries that make assumptions about what's available. One of those assumptions was that event emitters would be available. In my demo, my podcast demo, I didn't need that. I didn't really use much third-party stuff, so I could use the Angular event emitters, which are really nice because this is done on the scope, on Angular's scope. So Angular knows about these things. You don't have to run scope.apply to get the digest cycle going. So when you send a controller an event, it's gonna show up. So it's a really simple API. You listen for, you register for events with scope.on. And you say like, okay, IAM event is the string that's going to identify this, and then it's the second parameter is a function with two parameters, event and data. The event I never use at all, but data is important. And so then you can emit it with root scope.emit, and it's root scope because you're usually going to be doing this from a service. Services can't get scope injected, and they probably wouldn't be on the same scope anyways, so root scope is what you use. And
the syntax, I mean, the whole notion of it is fairly common standard event emitter type of paradigm that people are probably used to for any other system.
Mm-hmm.
It's just that these events get passed through the scope, so you do have to understand how kind of it goes up and down the scope.
Right, yeah.
Angular.
There are a couple options here, so it's depending on where you're firing events from and where you want to get them to, you might need emit or you might need broadcast. And they take the same parameters, but broadcast basically sends things down to children. Emit goes up the stack. So you kind of have to know which one you need. But yeah, event emitters are really useful, and they really help clean up code, and you don't have to have as many things explicitly calling one another. It's really
it just really helps keep your code structured in a really nice, clean way and modularized that way.
Right. Yeah. It really cuts down on interdependency stuff. And then I have just one other quick example of IndexedDB get. So very similar to put. This is just getting some item out of the database. This time we're gonna just use a key, which is can be a string, whatever your the type for your key is. And so we have a similar thing where we get the transaction out of the database with the store name. You don't need to be in read-write mode. You don't need to pass a mode in. The default is just read. And then the on-success case, again, we're emitting something onto, with Angular's root scope emitter. We say we've gotten this item, and then we're going to pass an array of results. So this is nice. With IndexedDB, like I like to always pass back the database name, the store name, and then the data, so that in my controller, like whatever is getting this data, if it's a service controller, whatever, I can first check to see, okay, so there's get item is pretty generic, right? And since this is a service library that I wrote, I'm not going to have dozens of different names for these things. I can, if I have common names and I pass back identifiers in the data, it just helps so that I can register the listener with that common name and then just sort of inspect things that come back on those event listeners when I get them. Yeah, so after you do your local storage, convert things to IndexedDB, it's still not going to work. You probably have some dynamic content that you need to handle.
And this goes back to the notion of the CSP of that you can't bring in external content and just kind of think it's going to run and all fine and dandy.
Right. So actually, this would probably be a good time to kind of explain one thing here. So this is my little podcast app that I did, and this is actually the Chrome app version. So you can see I launched it there. And so this middle section here, you can see, is all pulled in with a web request. So this side, the add podcast and list of podcast side, that's local. And then I have this section up top. This, you've got a playlist here on the left, that's local. But then the content with text, and that kind of pulls in information about either the show or all these episodes, that's all being pulled in with a web request. And you need XHR to do that. And it's a slightly different call that I had to make in the Chrome environment versus with just the Angular web environment. And so here's what you can use to get, say, an image. And this is an example of getting an image out of Imager. So I'm going to set it up with just a regular HTTP. This is Angular's HTTP thing that can be injected into your app. I'm going to say, the method's get. Here's the URL, and it's going to be a blob response, so that I can actually set it as the source of an image. In the success case, you get all this stuff back. Again, I'm going to sort of ignore everything except for the data that's coming back. I keep scrolling. And there. Yeah, so I'm going to ignore everything except the data. I have in my HTML this image tag with an ID that I specified, one pod under image. So I'm going to grab that, grab a reference to it, and then I can set the source with this window.webkit URL.createObject URL, and then the data. And it's going to allow me to just take that data that's the result of this web request, which is actually, works the same way as the XHR stuff. It's just a slightly different API, and then set that into the image. And then there's an error case where it failed, and hopefully it won't fail for you. And you also have to make sure that Imager is in your permissions. So this is not something that it's not my server, so I have to put it in the permissions thing. Once I do that, it should be okay.
Right, and you'll notice that there's other things that might need to go into your permissions. So any of the Chrome apps kind of require you to specify either, like what he said, which domains you might be getting external content from that you kind of put in your approved list, but also things like your storage here. You have to tell it that you're going to use storage, and even for your sockets, if you're going to use the Chrome socket API, you need to specify that hey, I'm going to allow TCP connections.
Right. Yeah, and then we're just going to keep iterating on this. So one thing that was kind of interesting was here's my controller to get individual episodes of a podcast, and I have this is the method here, make request, that's going to actually get the data for each episode, or for each podcast actually, and all the episodes within it. So I do the test up top to say, if it's Chrome storage, then I'm in the Chrome environment. There's probably a better way to do that, but that's the thing I used. And then we get this request URL, which is a really long thing. What's interesting here is I'm actually using a Google service. So with the content security policy, again, and since this is a podcast app, so I needed to go through a single place that's going to return the proper headers. So very basically, with an RSS feed app like mine, you want to be able to subscribe to whoever, right? And whoever may not have a server that's going to return you the headers that allow you to make requests, like cross-site requests to it. So what Google's done is to set up a service that allows you to get these RSS feeds from a single location. So I can say ajax.googleapis.com. I'm giving that one permission. It returns me back the proper header so that the requests are valid, and everybody's happy. The one big difference between the HTML5 version and the Chrome version is in the HTML5 version, I can actually use this .jsonp thing, which basically this returns as a callback. I don't really need this. If there's probably a way that I could get rid of this completely and do them both the same way, but it's a little nicer. This is how I was doing things before, where it was you see callback equals JSON under callback in the URL here, and that works with the this API. And then for Chrome, if you do that, it'll throw right at you and say you're not allowed to specify callbacks in in responses. So instead, you just do a regular HTTP GET, and then in the success you can still parse the data the same way. So that was kind of the only difference here, really. And then obviously the other thing is you've got to be able to load images, and as I showed you before, it's same deal. So yeah, and then you just iterate until you don't have any more red. There probably are going to be other issues that you'll run into outside of this stuff.
Right. So just to kind of recap, you have to really understand where the content security policy is coming from. That's going to be the major source for most of the errors. But you have to look into each of the third-party libraries that you use. A lot of them will make assumptions into kind of what environment they're working in, whether that be how they access sockets, how they access local storage, what they're used to be brought in. So if they use kind of an AMD or require style of being packaged up, right? You got to understand how that's all wrapped around those libraries.
Yeah. So I can kind of show. So here's here's the app in Chrome. Oh, I closed it out. Never mind. Yeah. So here's the app in Chrome. It's this stuff works. It remembers where you left off because I saved that information in local storage. So I have this method refresh interval. So every, I think it's 3 seconds until it's done playing, I send a message to say, update the last, update the progress with the current time.
And this gets saved into the local storage.
It gets saved into the local storage. Whereas, this data is saved in IndexedDB. I had originally wrote it with local storage, and I switched it over to IndexedDB and cut down, I just deleted a third of my code. It was really nice.
Right. And just to reiterate, the whole point of that is to make sure that the transition from an offline mode to online is smooth, right? So if you do lose connection, it does remember where you kind of left off. And that's really important for the whole user experience point of view.
Mm-hmm. Yeah. And there's definitely some other stuff that I'd like to get to in this app, like basically downloading the audio ahead of time, so that if you have no internet connection, you can still play your stuff. That I did not get to, but it's still a pretty functional tool. It's nicer than some of the other web tools that I've used, which is why I built it. So, yeah, and then we've got just throw up some links. that we'll make the presentation available to everybody so that they can kind of look at this stuff on their own.
Right. Yeah.
We have our our app that we're sort of modeling this talk on. This was actually, I think, basically all we really needed to do to get KeyChat up and running. I mean, we didn't. The content security stuff was more of a minor issue for us, and then we didn't really have anything outside of this that turned out to be much of a problem. It was a pretty straightforward conversion. It took me very little time to get up and running. Really just a couple days, and this is a pretty decent sized project. So I was very surprised at how quickly we were able to do the conversion.
Yeah, definitely. If you come from the Angular setup, it's really easy.
Mm-hmm. And then we've got Darrel's socket demo linked, which has both the server side and the client side in the same project.
Yes. Yeah.
And then I have 2 versions of the source for my app. So I created a couple branches so that you can look at before I started the Chrome app conversion and after it was finished. And these specific branches will not have any more commits, so they'll be exactly what I presented to you today. And then I wrote a couple little libraries that work nice with Angular and some of these APIs, like the IndexedDB and localStorage wrapper. And I have to get documentation up for those, but they work. So yeah.
Okay, good. Guys, thanks so much. This was a really nice introduction for Chrome apps and how, sort of the differences between an HTML5 app and a Chrome app. I think it'll get people started really quickly. And for everyone else, thanks for joining us today. We will see you on the web. We'll share all of these links to the presentation. We'll love to take questions on Google+ and Twitter. And we'll see you at the next GDL.
Yeah, thanks for having us.
Yeah, thanks for having us.
Thanks, guys.